When I first heard the words particle simulation, I thought that I'd have to know a lot about molecules, atoms, and particle physics in order to get started. Thankfully, that isn't the case. In computer graphics, particles are just used to create visually familiar things, like dust floating around in the air, sand laying on a seashore, or little pieces of dirt on a camera lens. In Blender, a particle is just a single point in space. Just like an empty or a vertex, it has no actual height, width, or depth. This approximation of the space that it takes up makes particles the least accurate of any of the types of dynamics. But the upside of this approximation is that Blender is able to calculate a whole lot of them at once. For example, my fairly old and average computer can calculate a few thousand in real time before dropping below 24 frames a second. There are so many awesome uses for particles, but the amount of settings available might make it seem intimidating if you're playing with them for the first time. There's a whole lot to talk about, but in this video we're just going to cover the basics. We can add a new particle system to any mesh object in Blender. To do so, just go to the Particle Settings tab, which is represented by 4 tiny stars, and click New. Now when we press Alt-A to play back our animation, now we have a bunch of little particles falling off our cube. All of these settings here on the right determine the attributes of a particle system. Now in this video we're just going to be covering the first Emission tab, because that's the most essential group of settings for any particle project. Now the first setting that you might notice is the number of particles. Let's increase this quite a bit, let's say 5,000, and you can see that we now have 5,000 particles. If we decrease this to 50, we're going to have 50 particles. It's important to note that these particles are spaced out throughout the entire animation. Unlike Trapcode Particular in After Effects or particle systems in Unity, it doesn't use a rate of particles per frame or per second, but rather it's stretched out over the entire animation from the start frame to the end frame. Let's change this back to 1,000. This is important to keep in mind because if we change our end frame to say 25 and play this back, you'll know that our particle system is much more dense than when it was at 200. Let's change the start frame and see what that does. As you might expect, our simulation isn't actually going to start until frame 10. You can tell this because on the timeline we have this nice little red line, and this indicates where the particle system is actually being cached. Now we'll talk about caching in a later video, but just be aware that this line indicates the duration of our simulation. And you can see that it doesn't start on frame 10, and it ends on frame 75, even though our end frame is set to 25. If we go back to frame 25, you can see that that's when the particles stop being emitted from the cube. So the end frame is not the end of our simulation, it's simply the end of when the particles are being emitted. Since the lifetime value is 50, we can see that the particles survive for 50 more frames until they finally disappear on frame 75. If we change the lifetime value to 25, you'll see that they won't live quite as long and they won't travel quite as far because they don't have as much time to do so. Let's change the start frame back to 1 and change the lifetime value back to 50. If we play this back one more time, you'll notice that all of the particles seem to disappear all at the exact same time. And it looks a little bit strange, like it's hitting an invisible wall and disappearing. And while this might be nice sometimes, a lot of the times we might need a nicer transition. For this exact purpose, we have a random value right below the lifetime. If we increase this all the way to 1 and play our animation, you'll notice that the particles start disappearing sometime in their life and we get a much nicer transition out. And they're not all disappearing at the exact same point. Now this random value makes the particle randomly choose a time in its life in which to cease to exist. So let's set our end frame to 50, and I'm going to set my end frame of the particle emission to 50 as well, and that way as we play our animation through, it can continue to loop. Now, if we change our random value to something like 0.5, it's going to choose sometime in the last 50% of its lifetime to die. So the lower that you set this value, the sharper of a transition you're going to get, and the higher you set this value, the smoother of a transition that you're going to get. Now let's set this back to 0. You'll notice that as we're looping through this animation, that we're getting this part at the beginning where it comes out of our cube and falls down all the way to the bottom. But in this case, since we're changing all these values and we'd like to see what happens to them in real time, it would be nice if they were already all the way at the bottom and in full swing in motion by the time we started the animation. And this is something we can do with a negative start frame. The way we do this is we just take the lifetime value, invert it, and put that as the start frame. So let's set this to -50. And by doing that, when we loop through our animation, let's start it again. Oh, I set that to -5. Let's go -50. There we go. Now when we start our animation, now it's going to loop continuously, and there's a little bit of a jump, so it's not seamlessly looping. However, it doesn't have that beginning transition. Now that we've talked about the number of particles and when the particles are emitted, let's talk about where they're actually being emitted from. By default, the particles are being emitted from the faces of the object. We have three different options. We can emit from vertices, faces, and volume, but since faces is on by default, let's take a look at those first. The first checkbox is random, and that's going to emit the particle on a random place anywhere around the cube. If we uncheck this, you'll notice that it's choosing one face at a time to emit the particles from. But when we check random on, it's going to choose one random place for every single particle, and it won't do this one at a time thing. I don't think I've ever actually unchecked that in a project, but you might find it useful, and it's good to be aware of just in case. The second option is for even distribution, but if we uncheck that, we won't see any difference because all of the faces of our cube are the same size. So I'm going to go over to layer 2 where we have this plane. If we go into edit mode, you'll see on one side of the plane we have a high density of faces, and on the other side we only have one face. So if we go back and play back our animation, you'll see that on one side we have a whole lot of particles being emitted where there are lots of faces, and very few particles where there's only one face. Now this is with even distribution turned off, because without it, it calculates the number of faces and distributes the particles based on that. When we check even distribution, it's going to instead calculate the surface area and randomly emit the particles from the surface area rather than the faces. Let's go back to our cube. Okay, the next few options we have are jittered, random, and grid, and these determine along which intervals the particles are emitted. So if we increase the particles per face, by default it's set to 0 and that just turns it off, but if we increase this to 1, you'll see that we only have one spot per face that these particles are being emitted. If we increase the jittering amount, you won't see much happening, but if we increase the particles per face to 2, you'll see that we now have 2 spots per face that they seem to be spouting out of. If we increase this or decrease this, it's simply increasing or decreasing the interval along which those 2 faces or 2 spots appear. Next we have random, which doesn't have any options because it's just choosing a random space along the face of the cube. We also have an option to show the grid, and you'll notice that when we have the grid turned on, the number of particles emitted is grayed out, and that's because it uses a resolution instead. I'm going to go into wireframe view so we can more clearly see what's going on. Now we don't see the entire grid being formed because we're starting on a negative frame. So let's set that back to 1. And you'll now see that as the grid moves through our cube, it's emitting the particles. We have a few options. We can either invert the grid, which doesn't invert the direction that it travels, but rather inverts the three-dimensional grid itself, or we have an option to choose a hexagonal grid, which just emits it in a different pattern rather than the square grid. If we increase the resolution to say 50, we can see this grid a bit more clearly. In case you don't want these lines to be quite so straight, we can increase the random value and it's going to jitter them just a little bit. Now they're not so straight. Now all of these same options for faces can be found in the volume. So we can have the same for jittered, random, or grid, but instead of being calculated on the faces, it's being calculated from the actual volume of the mesh instead. We also have an option for emitting from the vertices, and that's just going to emit the particles from each individual vertex. The random value is exactly the same as on the face, where it just chooses one at a time. Let's leave that checked. Now the very last checkbox is to use the modifier stack. And to show you this, I have another object on layer 3, and this object has a modifier applied. In the modifiers tab, we can see that we have a remesh modifier above the particle system, so it's being applied first. When we play back our particle system, you can see that our particles aren't actually being correctly calculated. Instead, they're just spouting from the object origin, and that's definitely not right. If we choose Use Modifier Stack, it's going to take this modifier into account and correctly distribute the particles along this object. So now that you know the basics of how to set up a particle system, I encourage you to try it on your own. In the next video, we're going to be talking about the cache and velocity settings, and then after that, you'll be ready to move on and create your own cool project.